I'm calling this XDebug, using XDebug for non-debuggish things. By non-debuggish, I basically mean profiling and code coverage, as opposed to just using XDebug. However, if you want and we have time, then I'm happy to go into quick overview of XDebug itself, after I talk about this. So anyway, what is debug? XDebug. It's a PHP extension. It's a compiled extension that is most easily installed either via apt or yum. PHPX. Sorry, you do apt get install PHP5 XDebug, and that's kind of up and running. It integrates with either a standalone debugger or your favorite IDE. It integrates with NetBeans, it integrates with Eclipse, Notepad++, Emacs, Vim, in anything you like. Anything I show you is going to be in Eclipse because I ain't going to touch Vim. It supports remote debugging, so you can have your code running on a remote server and have it connect to your local development environment. It provides some helper functions, timing functions, and better access to call stack information and things like that. It provides profiling information, which is what we're going to talk about tonight. When it does its profiling, it outputs call grind or cache grind compatible output, which means that we can use that output, we can open it in any application that is call grind or cache grind compatible. That's generally the stock standard way that most languages will dump debug information. Like if you're debugging a C program, you're probably going to do it with call grind or cache grind. And it also provides some code coverage. Even though it does that, it's better to use PHP unit, I think, to show your code coverage, just because what this outputs is usable to a point. Well, not really, but it can be used by PHP unit to make really nice reports, and we'll have a quick look at that as well. So anyway, our goal for this test program that I'm going to show you tonight is we're going to populate a database with a fresh list of up to 10,000 random strings, but it's never going to run more than 10 seconds. So our goal is to essentially get as many strings into the database as possible within 10 seconds. So I guess we can have a quick look at the code, and this is where things will probably fall apart. Okay, so basically I start at the top here. I declare ticks equals 1. I don't know if any of you know that, but basically ticks in PHP are essentially an operation in PHP. It has this little thing and it does a little thing in PHP, and then the machine will say that's a tick, right? And then it'll do another little thing in PHP, that's a tick, right? So by declaring ticks equals 1, and then down here we register an anonymous function with the register tick function, and that's basically saying every time I hit one tick, call this function down here, right? So it doesn't matter where you are in your code, it'll jump back to that function, execute it, and then jump back to where you were, right? So I have the end time defined here as now plus 10 seconds, and then in this tick function that I'm registering, I have a global called random strings. It's just going to be an array, and basically if the current time is greater than the end time, so if I've hit the 10 seconds, I am going to count the number of strings in the array, and I'm going to die with this comment telling us how many strings we have. So that's relatively simple, I think. We have the generate random string function here, where I just pass in a length or not, and it'll create a random string using A to Z, 0 to 9. So they're the kind of helper functions. This is the main piece of the code that we're going to use. I create a database connection, I truncate the table, I'm going to create up to 10,000 strings, I declare my array, and then while I have less than the number of strings I'm looking for, I'm going to generate a random string. If it's not in my random array, insert it. Otherwise, kind of what I'm going to try and do here is, if it's not in the array, I want to, reset everything, clear it all out, try again type thing. So, obviously this is not a real functioning program. It works, but it doesn't do much. But hopefully it'll kind of help us show what we're trying to do here. So, back to here. Okay, so the tools that we're going to be using, like I said, we're using XDebug to output the profiling and the code coverage information. and kcrashgrind to process the profiling information, and PHP unit to give us better coverage reports. Oops, I just want to go back to here for a sec. We're going to use two XDebug settings. One is the profiler enable thing, enable, which tells XDebug while you're running, or while the code is running, I need you to track the profiler information. I'm going to define the profiler output directory, which will just tell it where to put the file. I'm also going to set the output name, so I can do that. And that's it for now. That's all that really matters. So, let's jump to the command line and see what happens here. Okay, so I've got my version 1 of my code here. And basically I'm just going to, what have I got here? This is the command I'm going to run. You can see here, I'm just going to run PHP. I'm going to say XDebug profiler enable equals 1. I'm going to say XDebug profiler output directory is here. XDebug profile output name is cashgrind.out. And then I'm going to run xdebug.php after it. These things are obviously all things that can be set in the PHP ini file, but I'm just going to declare them here so that we have them. Okay, so when I run this, we're basically going to see it. It's going to run for a maximum of 10 seconds. And let's just see what happens. Okay, if we see a little dot come up, that means it's found 1,000 strings that is put into the database. And we didn't get much at all. And I wish this screen was a little lower. Okay. So anyway, we got to 188 strings before we hit the 10 seconds. Now, that's fine, but the question is, why are we so slow? Thankfully, like I say, we created cashgrind.out file. So let's jump into kcashgrind here. This is another program that you can just install via apt-get. There's a Windows version. There's pretty much a version of an application like this for pretty much every OS. So let's open our cashgrind file. So we can see over on this side of the screen, this is basically like the top level file that we called, right? It's 100.06%. I don't know if that's a rounding issue or if maybe that's extra 0.06 might be related to the XDebug, the time it actually took to write the profile, I'm not quite sure. But basically, so at 100%, that's the main function. If we go down here, we can see that 95.68% of the time that we ran, we were calling PDO query, right? I can do this better over here. And it was called 189 times, right? We see here, this is a closure, this is our tick function. It was called 5,600 times. It only took 1%. This is a percentage of the time that these files took up, and the number of times it's called. Over here is actually like a visual representation of this, right? So I mean, this is a PDO query. You can see down here that there are other functions that were called, but they're practically useless. And even this here, this is the call graph. It's all stuck here, right? Nothing else matters, basically, right? So, I mean, what now I would do, and what I have done, is I would go back to this code and say, okay, what can I do to improve the call to PDO query, right? So, what I know is that if I'm calling this query every time, it's going to essentially implicitly create a transaction. It's going to write the thing. It's going to write to the database. It's all going to be slow, right? We learned this, Alex. I learned this when we were doing the real estate data. We were running a script that we were projecting was going to take 46, 47 days. So then we said, okay, let's just use transactions. So we would start a transaction. We'd dump like 100,000 in. We'd write it. We'd commit the transaction and go on. And it sped it up to like 4.5 days or something like that, because it wasn't explicitly committing at the end of everything, right? So this is basically what I do when I'm trying to profile. I run this kind of thing. I look at what's my main offender, and then okay, what can I do to fix this? So let's just assume, because I have, that now I've explicitly created a transaction at the top here. I call the commit here, and at the end, I call the insert here, but it's not until I've actually got through to the end of the script that I call the commit. the one other thing that I have to note is that I also have to do this commit up here, right, in the register tick function, because if I don't get all the way to that end of that 10,000, that's where I'm going to die. So I want to make sure that I still output to that. So I do this, and then I basically run the profiler again. So you can see now we're actually hit 3, 4. These are thousands of transactions of inserts. So we got to almost 5,000 strings just by doing that. And then I can see how that's affected this by opening my new grind file, and it's way more interesting now. All of a sudden, like here's my query here, it's only taking up 10% of the transaction now. Have my closure there. It's actually, this now is actually this is the tick function. This is actually starting to take, you know, quite a bit of the time. And this generate random string function here. And you can see also that the call graph is more interesting now because we actually have more to use.
What's the significance of some of them stacked up, some of them lying down?
It was basically just the way for it to fit it into a box, right? And I mean, if I was to like...
Oh, is it like that could be a pie chart kind of thing?
Yeah, that's basically what it is.
Okay.
And if I click on generate random string, like that becomes the master box. And this is basically all the stuff that happens because generate random string calls functions itself, right? This is basically well, what happens within the generate random string function. I can see that in there, 20% of the time is here, this is all this sort of stuff. So if I'm just curious about, well, I saw that here I could see the generate random string uses 58%, and then I can just kind of drill into that a little bit more if I wanted to. So because now I knew that was going to happen, and now I'm all over the place. Because now we can see that the tick function is actually using 20% of the time, I'm going to quickly change that just so that I can kind of show you something here as well. You can see down here, because I was calling time, you know, I was saying 10 seconds. It was running about 2, well that got right on 10 seconds practically. This was 10 and a quarter seconds. There's always going to be a little bit of time because if you're calling like DB query and it's sending stuff across to MySQL, the tick is not going to interrupt that. It's going to wait till the DB gets a response from the database, and it'll tick. So if we don't care too much, you know, if we can accept that maybe every single tick is a little too aggressive, we could maybe change that up a little bit, and let's just see what happens there now. Right, so now I've just changed it to 100. So every 100 PHP operations, that's when it'll call this register thing. So whereas before, you know, what we were really trying to do is shave off some time or to improve the number of strings that we can get in. This isn't really related to that. This is more saying, okay, well, you're now being too aggressive. You're doing stuff that's really not going to really affect the outcome, because the outcome that we're looking for is run it for as close to 10 seconds as we can get. So now this is a little bit different, right? We're saying, well, you know, we can ease up on that because maybe 10.1 seconds is acceptable, right? So by changing the number of ticks before we call the function, we can once again run the profiler. I'll close these two off while that's running. Actually, I won't close that one. And now we see we actually got 9,200 strings, right? So that's because all of a sudden it's not every single time, as often as it can, calling back into that function just to see if we've got too many strings.
Is your code putting up those dots?
Yeah.
Or is the tick coming?
No, that's my code. Yeah, it's every time
that tick function, was it?
No, it was actually in the loop. Every time it got to insert 1,000 strings, it would output a dot. You can ask Alex and Nick. Favorite thing that my code does is output dots on a screen.
Good.
Sometimes if I'm feeling really, ooh, I might put out an X, but generally it's dots. Now all of a sudden, you know, again, this whole thing changes. Right, here's our random string here. it's a quarter of a thing. And the important thing is we saw that we were able to double the strings, right? And we didn't actually affect the runtime at all, right? So that's another improvement that we find from the profiler. Now we see that PHP in array is causing us a problem, and I know this is starting to get a little repetitive, but I just wanted to show one extra thing, with regards to this, and that's not going to do this for me now. So one kind of interesting fact about this is that this is all, it shows function calls and things like that. One thing that you won't see in here is language constructs, which generally don't matter, except in the instance that I'm going to show you. Right? That in array was using up a fair amount of time. So what I want to do is thank you. What I was doing is, as I was checking to see if in here I had this random strings array, and I was just appending the string on the end, right? So then as the string got longer, every time I went to check the new one, I had to call in array. I had to scroll over that array just to see if it was in there. So just changed it a little bit to say, why don't we use the string as the key, right? And then it can actually, it can look straight into the spot where the key would exist, all right? Instead of having to scroll all the way through the array. Does that make sense? Okay. So anyway, with that in mind, I just wanted to kind of throw that out there and say, okay, well, let's see how that performs, or at least how that changes the profile of the application. There you go. And we actually completed the 10,000 in 4.84 seconds. So by using the profiler, we were able to go from 198, whatever it was, strings in 10 seconds, down to 10,000 in less than 5. And obviously, this is a made-up example, but it kind of shows the point. And just to see it now in the cache grind here. We can now see, it's kind of pretty nice here. You can't see that is set because that's a language construct. It's not a function in and of itself. Generate random string is still going to it's taking up the most amount of time. And I mean, we can talk about trying to improve that. But I think it's kind of getting a little boring now, to be perfectly honest. So that's that. And that there is basically, what cache grind is all about, and profiling. Yeah. Was it up, down?
It was more of a to me, there was a time when I didn't want to scroll, but I forget what it is.
How do I know?
It's not that important. It's just more of a thing like you're dumping stuff into a memory.
I'm actually in this code here. It's
can you make the transaction as big as you want? Like you're forcing things into memory, right?
well, I mean, it's forcing it into MySQL magic. I guess it's sitting in memory.
Before you miss.
Yeah.
You're storing things.
Oh yeah. I'm putting it into an array.
Right.
Yeah.
But the transaction waits.
Right. Yeah, until it's
done. You don't have anything in the transaction when you're dumping that into the database.
Right, when it's complete.
How do you control the transaction? Can you make that smaller or bigger? Like if can you make that?
I mean, you can do it however you like. I wouldn't want to try and hack this code into doing it easily in front of you.
No,
but yeah, I mean, you can just, yeah.
It's a way to save even more time, like not commit as often if you're able to make that.
Right. Well, I mean, this code only commits right at the very end of the script, basically.
Right, but can you make that bucket bigger and therefore go to the database less often? That's another way of making it.
Oh, I see, yeah. I mean, you could probably do like a you could probably string the inserts into a single insert, maybe. Is that what you mean? Like go insert into string list, ID string values, and then, because you can pass it multiple sets of values, and it'll just be a single query across the database. I mean, that's one way you can do it for sure. I don't really want to. Yeah, I mean, this is the beauty of it, right? You can also you can see it and run things, and you can tell whether or not it's actually any good.
Can I ask a question?
Yeah.
When you're showing the output,
Yep.
it's showing percentage there. Is that of time, or is that of CPU, or you know what I mean?
Yeah, I am.
Because some PHP functions use a lot more CPU than others, like eBay.
Right. I think it's time.
Okay.
Yeah.
That's really like eBay would use more. Like the thing is, I remember being in a situation where use this to figure out why stuff is making the load act control.
Hmm.
Change it, but it was.
Oh, okay. Yeah.
So I just wondered whether this could show that.
I mean, I know that like cache grind by itself, I'm pretty sure it can support like tracking of IO operations versus it supports a lot of other stuff, mainly for the C level things. I don't really know if I can have a look and see here.
It's at the top right there. It says time up there.
Oh yeah.
You can switch that to see if it records anything else.
It doesn't seem to.
Yeah, so it was
Huh?
cycle detection.
Cycle detection.
Between that's the.
Oh, this here.
That's it.
That's interesting.
Yeah, I mean, I guess in that instance, yeah, you'd find it hitting the CPU because all the rest of the script was probably like IO bound or something like that. Like it might have been waiting for input. It's kind of, yeah. Sorry? Yeah. Yeah. Great. So I mean, that's basically
That
the.
question deserves a lobster.
There you go. Good point.
Wow. That is awesome.
There you go.
Still a grind. You didn't even get an
Bad reputation.
Okay, so the important things that we get from the profiler results, we get to see where we visually can see where the problems are. If we're throwing around these ideas of, well, maybe this code works, maybe that code works, we can visually show the improvement, and we can back it up with numbers, as opposed to coming in and saying, well, I think it feels faster this way, whatever. Or even sometimes you do the code and it is faster, but the reason it's faster has nothing to do with your reasoning, right? So you can look at it and go, oh, well, that's because it ended up going this way, and therefore I need to trim this or whatnot. And I mean, just as equally important is we can show non-improvement with numbers. Again, we don't really know, but it feels faster, or we can show and say, well, that's not actually true. Or more importantly, you might have this chunk of code that's really easy to read. You can replace it with something super complex, and you might be able to show, okay, well, it shaved 0.5% off the runtime. Is it really worth trying to maintain that going forward? Okay, so just going back to the profiler settings that I was using on the command line. We use profiler enable that tells XDebug, doing all your other stuff, which we can talk about later. We also want you to dump profile information. We can tell it where to output the file. We can tell it what to call the file. Other settings we could have used are profiler enable trigger, profiler append. I should have known that. So the cool thing about output name is it allows you to put in a wildcard into the naming convention. By default, it's something like cachegrind.out.%p, and the P stands for process ID. So every time you run PHP, it creates a new PID, and therefore you get a new output file. But for that wildcard, or that whatever you want to call it, you can have it use the a checksum of the current directory. You can have the PID. You can have it use a random number. You can have it use the script name. You can have it put in a timestamp. You can have it put in the request URI, right? Because obviously this stuff all applies to a web request as well, right? And by using profiler enabled trigger and profiler append tells XDebug when you're outputting to this particular cache grind file, by default it will override it, right? But profiler append lets us continually add more and more information to that file. And the profiler enabled trigger, we can disable profiler enable, right? But we can enable the enable trigger, and that says don't do anything unless you get a get variable or a post variable or a cookie with the name, it's like enable profiler or something like that. So basically that lets us dictate when we want it to output. And by using profiler append and the profiler output name with the request URI, we can turn it on for a little bit, or just from one particular browser, hit a few pages in our browser, and it's all broken down into this web page here. This is all the cache grind stuff for that. This web page here has this cache grind information and so on. Actually, and just to show you what a core grind, what one of those multiple output files look like. I'm just going to run this for 2 seconds. I'm just going to, this multi-profile script that I have here, it's just set up to append to the file instead. And now I'll come over to cache grind. And I lose my mouse. So there was the original request that was already existing in the file. Then I ran it 2 more times, and you can actually see here. So it's broken it out into the 3 requests, and so you can actually kind of jump around, see how it changes and things like that. So I think that's kind of cool too. Okay, so the other, besides profiling, the other thing I wanted to quickly talk about was code coverage. And like I said at the start, we can use XDebug to create the code coverage information, or we can use PHP unit. So just to show you the differences in that output. So here is the code that we would use to enable XDebug to output the coverage information. At the top here we can tell when to start the code coverage, and this is basically saying, this bit here says, don't just show me the lines that are actually touched, I also want to see the lines that weren't touched and the lines that couldn't be touched. Right, and that's all you have to do up the top there, and then at the end of when the code finishes running, we just say var dump, there's XDebug get code coverage, and that returns an array, and I've just got a var dumping to the screen so that we can see what that looks like. And it'll run for a little bit, and it's going to output all this stuff. But this is a single array. Well, it's actually not, it's a multi-dimensional array, sorry. Oh, come on. Right at the top, we can see there's the file name, right? We're only using one file, so it's kind of basic there. But otherwise, if we're using big files, it'll break it all down into separate files. And then it's every single line number there that actually has code on it, right? So line 7, it got touched. Line 8 got hit. 10, they all got hit, all the way down to here. Line 14 didn't get hit, ever, during our code run. So let's just have a quick look at that. Well, that's because we actually, this is the tick function that we never actually got a chance to stop on, right? Because we actually finished before we hit the end time. So those lines there never actually got hit. And the other interesting value, so that's -1, -2. Like line 18 here is a -2. And that is dead code, right? That's code that's never going to get run. The reason for that is This line here can never be run because the line before it is a die function, right? So if you're going to die, the rest of the code is useless. You know, if you have a return and then you have code afterwards, that's dead code. They ain't going to get run no matter what. Right, so you can kind of get an idea of what's going on there, but it's kind of useless. This is where I prefer to use PHP unit. And if I so can I see that? Actually, I can bring it up like this, can't I? What I'm going to use is I'm going to call PHP unit and pass it this variable coverage HTML. This is the directory that it's going to dump the information into. And I'm going to run XDebug test.php. XDebug test.php is simply you're going to make me reset this, aren't I? Refresh. I don't know, have you guys used PHP unit much? No? Okay, a little bit. So basically we call the function with the word test at the end, the file, sorry, and that's the file that PHP unit is going to, it sees that test file, it opens it up, it looks for a class with the same name, so we call the class XDebug test, it extends PHP unit, this is just how you do unit testing stuff here. And then you have multiple functions inside PHP unit, and each one is essentially a test. This is obviously not a real PHP unit test. I'm basically dummying up the code and hacking it into a test so that I can get PHP unit itself to write the code coverage, right? So this is not how you would normally write a test, but it's the easiest way to get PHP unit to create the coverage. So if I run that, come on. Now we can see if I work out, it'll be over here. Don't look at me. So again, we only have one file, so it's kind of useless. If we click on here, we can see all the red lines are stuff that never got touched, never got executed, and the green stuff is stuff that obviously did get executed. So we can scroll down here and we can easily see that we never actually tested. I mean, if this was a real unit test, right, we would use the code coverage output that XDebug provides PHP unit to quickly look in this and say, you know what, we haven't done a unit test that executes this code yet, right? So we can't say that our code is tested yet. And if I were to actually fix this code up to run, it would actually throw an error because I'm using a query that's not right there. So once again, we use XDebug, this time in conjunction with PHP unit, to easily see what parts of our code need us to look at as far as testing is concerned. And let me just see what else I've got here. Oh, I see, that's that. So again, with code coverage results, we no longer have to try and guess what code is not getting touched. You know, again, we have this visual representation. The code coverage reports from PHP unit are spectacular because it also tells you this function has 61% of the lines touched, this function has blah blah blah. So that's kind of cool as well. And that's it. So yeah.
Woo!